Welcome. Today we are diving into the heart of object-oriented programming. We'll learn how to use inheritance to create hierarchies that minimize repetitive code and polymorphism to write flexible functions that treat different objects as if they share the same base structure. Think of inheritance like a family tree. A child class inherits DNA from a parent. Polymorphism is like a universal remote. Whether you are pointing it at a TV or a sound system, the power button works the same way, even though the internal mechanics of those devices are totally different. First, we define a base class, or parent. Here, we create an animal class with a simple method called speak. This acts as the foundation for any specific animals we might create later. It's the shared starting point for all our future subclass. To create a subclass, simply put the parent class name in parentheses after the new class name. By passing animal into dog, our dog automatically gains access to all methods defined in the animal class. Even with just the pass keyword, the functionality is inherited. Here, the cat class inherits speak from animal but also adds its own unique method, purr. You can see that calling speak on a cat instance still works perfectly. Inheritance allows your objects to grow specialized features while keeping the base functionality intact. Sometimes, the parent's method isn't quite right for the child. Method overriding lets you redefine a parent method in the subclass. By defining a method with the same name, the child's version takes priority, allowing you to provide specialized behavior while keeping the same interface. When you override a method, you might still need the logic from the parent. That's where super comes in. It returns a temporary object of the parent class, allowing you to call its methods, like initializing common attributes, before adding your own custom child-specific logic. Polymorphism literally means many forms. In programming, it allows different objects to be treated as instances of the same general class through a shared interface. You can call the same method name on various objects, and each object will execute its own specific implementation of that logic. Here, we store a list of different animal objects. Even though they are different types, they share the speak method. We simply loop through the list and call speak on each item. Python handles the rest, executing the correct version of the method for every unique object type. When working with complex hierarchies, you often need to verify relationships. Use isInstance to check if an object belongs to a specific class or its subclass. Similarly, use a subclass to confirm if one class is derived from another, which is essential for safely managing your object structures. One of the most common mistakes beginners make is forgetting to call the parent class constructor when overriding the __init__ method. If you define an __init__ in your child class, it replaces the parent's version. You must manually call super.__init__ to ensure the parent's logic and attributes are correctly initialized. Time for a quick check. If you want to make sure your subclass inherits the setup logic defined in the base class, which approach should you use? The correct answer is C, super.__init__. This correctly invokes the parent's initialization process before your subclass adds any specific custom logic. To wrap things up, remember these three core concepts. Inheritance allows you to reuse logic, keeping your code dry. Polymorphism gives you the flexibility to treat different objects through a single interface. Finally, use these tools to model your programs after real-world hierarchies, making your architecture more intuitive and maintainable.